So I'm going to be going through the graphs of reciprocal trig functions from our trigonometric graphs, Unit 11. This is going to be a little longer because we have to do 3 or 4 graphs in here. So I'm going to go as quick as I can and try and make it as painless as possible. So to graph secant, cosecant, and cotangent functions, we use the reciprocal of sine, cosine, and tangent. So there's several important things you need to remember. The first thing is that the reciprocal of 1 is also 1. Because if you flip 1 over 1, it stays the same thing. Also, the reciprocal of negative 1 is still negative 1. Because if you flip it over, it gives you the same value back. So therefore, anywhere sine, cosine, and tangent equal 1 or negative 1, the reciprocals will also equal 1 or negative 1. So at those places, whenever it comes up to the top or gets down to the bottom, these places, these graphs are going to stay the same right there. What's in between them is going to change though. Next important thing is to remember the reciprocal of 0 becomes 1 over 0, which is undefined. So whenever sine, cosine, or tangent equals 0, the reciprocals will be undefined, and therefore their graphs will have an asymptote, or one of those dotted lines that, remember when we were doing exponentials and logs, it comes up and it gets really close to it but never actually touches. That is what's going to happen in our graphs now. We're going to have asymptotes in there. We need to remember the reciprocal of a positive number less than 1 is a positive number greater than 1. And if we have a reciprocal of a negative number greater than 1, it's a negative number less than 1. Sorry, less than negative 1. Originally, the range for sine and cosine was from negative 1 to positive 1, with these hard brackets here, meaning that they were included. Now, for cosecant, which is 1 over sine, and secant, which is 1 over cosine, our new range is going to be from negative infinity to negative 1, and from positive 1 to positive infinity. So when you see what happens to the graph, it's almost like they flip over, like they break apart and are going in the opposite direction. So let's look at our first example here. And it wants us to graph y equals secant of x on the interval from 0 to 2 pi. So we need to go ahead and graph our axes. So we'll draw our y-axis, our x-axis, and then we need to put in our pi over 2, pi, 3 pi over 2, and 2 pi. So if we're graphing secant, that's 1 over cosine of x. So we're going to start with the cosine graph. And for the first one here, I want you to graph it with me. For the rest of them, I don't want you to graph the original. So for cosine, normally it starts at 1, goes to 0, down to negative 1, 0, and back up to 1. And if I were you, I would definitely try making a little bit of a dotted line here. So we start at 1, curve down, and back up, something like that. So if you look up at what we just said a minute ago, we know that wherever there is a 0 is going to now become an asymptote. So we're going to have an asymptote here, and we're going to have an asymptote here. Also, wherever something is equal to 1 or negative 1, it stays the same. So this point at 1 is going to stay the same, and so is this one over here. This one at negative 1 in the middle is also going to stay the same. But now, instead of curving down, this piece is actually going to curve up towards that asymptote. Just like this other at the end over here is going to do the same thing. This is going to curve up towards the asymptote. The bottom is going to do the same thing. Originally it was kind of a curve like this. Now we actually want it to curve back down towards the asymptotes. And remember, they'll get really close to those, but they'll never actually touch it. So I know I can erase this. I'm not sure if you can or not. But the graph of secant is actually going to look something like this, if I take out that original curve. So now you have pieces curving up, making a little bit of a U, and then the same thing here. And again, if this continued, it would make the rest of these curves up towards the other asymptotes, but it's only asked to graph from 0 to 2 pi. So let's look at the next graph, which is now y equals cosecant of x. So remember, that's 1 over sine x. So I'm going to go ahead and put my lines in here, as you should on your paper. And I'm going to put my labels in as well, so you can do that also. And I'm going to graph the original sine function, but I don't want you to do that on your paper, because you can't erase it, so I want you to have just the reciprocal function. So sine starts at 0, goes to 1, 0, negative 1, and back to 0. So it's going to look like this. And now we're going to have asymptotes wherever it equals 0. So we have one asymptote here because it equals 0, an asymptote here because it equals 0, and then 1 over at 2 pi because it equals 0. So remember, that's because our graph crossed the axis there. And when you flip it over, you can't have a 0 in the denominator, it becomes undefined. Also, wherever it's 1 or negative 1, the function stays the same. So when you graph y equals cosecant of x, it actually ends up being a u up here and an upside down u, or an n, down at the bottom. That was really poor drawing. And remember to put your arrows on, because it does go on forever towards those vertical asymptotes there. So you've basically taken this curve and broken it up so it's facing that way, and this one flips and is facing the other way. So that is y equals cosecant of x, or 1 over sine x. The last one is graphing cotangent. Now cotangent's a little bit different because it doesn't have that sinusoidal shape to it. So I'm going to put my axes in and label them, as you should as well. And if you graph tangent, which I'm not asking you to do, there were already some asymptotes in there. So there were already asymptotes at pi over 2 and at 3 pi over 2. And our graph of our tangent function looks something like this. And it crossed through 0 here, here, and here. So now our new asymptotes, let's pick a different color. Let's do blue. So our new asymptotes now are going to be at 0, pi, and 2 pi. And our curves are actually going to be going in the opposite direction. And anytime that the function is undefined, that actually becomes a place where the graph equals 0. So at pi over 2 and 3 pi over 2 is where tangent is undefined. So that means that's where our cotangent is going to equal 0. And it's going to be going in the opposite direction. So cotangent actually starts at the top and does like a reverse of what tangent does. It comes down, sweeps through 0, and goes in the opposite direction. So again, I should have said this previously, but without the tangent drawn in there, your cotangent looks something like this. It's just those kind of crazy propeller things going in the opposite direction though. And again, all of these would actually continue in both directions as long as you're asked to go. The final graph here is adding some more stuff in now. So this is asking you to graph y equals 3 secant of 2x going from negative pi to positive pi. So I'm going to draw my axes in there. And, oops, wrong place. And this time we're going from negative pi to positive pi. So I need my axis to be in the middle here somewhere. And then again I want to put in my numbers here. And I'm ready to go. So, the initial function being secant means that we're looking at 1 over cosine. So, cosine starts at 1, goes to 0, and down to negative 1. And then it does the same thing in the opposite direction. So I'm not going to draw that in. That would be your initial cosine graph. Well, this is now saying that we want secant of 2x, which means that that's our frequency, so it's going to be happening twice as fast. So if we were doing a cosine graph going twice as fast, it would start at 1, go to 0, negative 1, 0, and 1. So it's going twice as quickly through this. And the 3 out in front there, we know is our amplitude. So now we're actually going to jump from 1 all the way up to 3. So our points will be at, will be at 3 and negative 3. And I just realized that this is going to be a really poor way to do this because we need to flip it over still. Our asymptotes are going to end up wherever our function is at 0. So our function is at 0 here and here, and going in the other direction we have asymptotes here and here. And now, like I just said, this is going to actually turn out kind of poorly because we're already off the graph. Because normally our cosine graph would curve like this, but that's not where we want to go. We want to be the broken piece of that because we're graphing secant. So these curves would actually curve up here, and you might have room on your graph to do this. You'd have one going like this, the next one curving up from here, curving down like this, and then just half of one on the end. So I guess I should have maybe, instead of using each of these as one, I should have broken it up more so that it was going by ones instead of by twos there. So this should have been 1, 2, 3, 4, 5, 6. So we would have a little more room. But that's okay. You still get the idea. The important part about this is that if you're graphing y equals 3 secant of 2x, your amplitude, your frequency, your vertical and horizontal moves all stay the same. The only thing that changes now is instead of having that curve going through all those points, now you have the other curves going up and away from your axes. I know that's kind of confusing, and I tried to keep this video as short as I could. We are going to go through another example tomorrow, just so that you're able to see exactly what's going on. Other than that, though, come in with any questions, ready to do a little bit of practice, and I will see you tomorrow.